Everyone, in this video tutorial, we will simulate compression test of concrete cylinder using Abaqus. We will go through all necessary steps to run our job successfully and get this result of failure and damage of our concrete cylinder under compression test. We will get also the curve of force displacement, and also we will see the failure and damage of our material in our cylinder. Let's get started. First, let's start with creating of our concrete cylinder specimen. First, let's go to create part, name it cylinder of concrete, 3D deformable solid extrusion, and click continue. And now let's create circle with radius of 75 millimeter, and click done. And now let's add our length of our specimen equal to 300 millimeter. Now we have our specimen of concrete test, of compression test. Now let's create two datum plan. First one, the XY plan to create partitions, and the second one is the ZY plan. And now let's create offset of our datum plan. From the bottom plan, enter value, click OK, 150 millimeter. Create partition in the middle of our specimen, of our cylinder. Now let's create partitions. Select cell, create partition, select cell, use datum plan, select datum plan, create partition. Now we have the first partition, and let's add another partition in these two cells. Select two cells, click on, select datum plan, and click create partition. Now we have the right partitions of our model. Now let's add another datum plan in this direction, the ZX plan. Create one, offset equal to 0, and now let's create partitions of our cells. Now select cells, create partition, cell, use datum plan, select cells where we need to create partitions, click on, select datum plan, click create partition. Now we have the right partitions of our part. Now let's go to property module, and let's import our material library and select concrete material. As you can see here, we don't have any material in our model. Let's double click on the material in our library. We have concrete 2 library of material. We have imported material in our model from library. Let's edit this material, and we have density, elastic property, and concrete damage plasticity. We have dilation angle, eccentricity, and other parameters of concrete damage model, concrete damage plasticity model. Now we have concrete compression damage and also concrete tension damage. We have also compressive behavior of our concrete material, and also we have tensile behavior of our concrete material. And we can select sub option to create concrete damage tension and also concrete damage compression. Depending to your property of material, you can use in your model. Now let's go to create section, concrete section, solid, homogeneous, click continue and select material, concrete, click OK and assign this material to our part, click done and click OK. Now we have assigned material to our cylinder for compression test. Now let's go to assembly and create instance, apply, and now let's go to step and create dynamic analysis step for our analysis. Step 1, dynamic explicit, click continue and click OK. Now let's go to interaction. We have just one part, we don't need any interaction, but we need to create reference point to apply our displacement load. Let's create a reference point in the top of our part, select the middle point. Now we have a reference point created in this point. Now let's create coupling, interaction, constraint, create constraint. We need to go to create constraint. You can select tie and click continue and select surface where we need to create our interaction tie. Select surface, select these top faces or surfaces, click done. Now we have a wrong selection. Let's go to create coupling, not tie, coupling, continue, select reference point of our coupling, click on select surfaces of our coupling interaction and click done. Now we have this point as master point and the surfaces in the top of our cylinder as slave surface. Click OK and we have constrained degree of freedom and also coupling type. Click OK. Now let's go to load and create our load in our part, and we need to fix the bottom surface of our cylinder. Create step 1 in the initial step, displacement, continue, click done. We can select encaster, OK, or you can select any other boundary condition depending to your model. And also in the bottom, in the top surface of our cylinder, also in the initial step, create new one, initial step, displacement rotation, continue and select these surfaces in the top of cylinder and select the X and Y to avoid the movement in these two directions and click OK. Now let's create our load as displacement in the Y direction, in the Z direction, displacement in the initial step, in the step 1, click continue, and now we need to select a reference point, click OK and select the displacement in our test. Let's add minus 2 millimeter, and now let's create, we need to create amplitude for our load. Let's create amplitude, create amp1, click continue and create our amplitude for the dynamic analysis. select, click OK, and select this amplitude and click OK. Now let's go to step analysis and select the type of output data. Let's select failure criteria and fracture and select damage of compressive damage and also the tensile damage of concrete, and also select status to show our failure and remove our elements deletion. And now let's go to every x unit time for frequency and select 0.1 or 0.01 and click OK. Now let's go to mesh module and mesh our part, our cylinder. Select the size, select 5 millimeter, click OK, and mesh our part. Now let's go to assign element type, select part mesh, and select explicit from element library, 3D stresses, linear, reduced integration, and also don't forget to select element deletion and select yes to see our deletion of the damaged element and remove the damaged element and remove damaged parts. Now let's create, select, click OK. And now before to go to the job and create job and submit our job, let's go to model and edit keyword, select model, and now let's go to concrete tension stiffening, and select add after, and let's add this statement, concrete failure, and also add some value of our concrete failure. The first value is the fracture strain for compression equal to 0, semicolon, and also the value of the first one is the fracture strain of tension equal to 0, and the second one is the fracture strain for compression equal to 0.0095, for example, depending to your property. And also the third value is damage parameter for tension equal to also 0 for the tension, and also the, the damage parameter for compression equal to 0.935, for example, depending to your property. Now click OK. Let's verify if you have this modification in our statements. Let's take a look at, now we have this value. Okay, now let's go to job and create our job. But before we go to submit our job, let's go to step and create mass scaling to make our simulation run faster. Select use mass scaling definition below, create and scale by factor, and use 1000 for example, and click OK. This value make our simulation run faster and take less time to run our job. Now let's go to job and create job. Test one will or completion test. Click continue. Click OK. Now let's check our model first. Check simulated. Check running. This operation is take time. It's take time to verify if you have any problem in our model before go to running and simulating. Completed check. Let's go to continue our submission. Click OK. Now we have aborted situation, but let's go to check our result. Go to result and let's see our deformed shape. As you can see here, we have this damage. Let's plot animation and we can see the failure and damage of our cylinder under compression test. Now we have this damage in this part in the model. The first damage in the initial damage of our cylinder, and we have the wall damage and failure of our concrete cylinder and the compression test. Now let's go to hide unnecessary edges. Apply. Okay. And let's plot our force displacement curve of our test. Go to ODB file output, continue, and select unique nodal and select displacement in the Z direction and reaction force in the Z direction, reaction force in the third axis, and also the displacement in the third axis. Let's select node set reference point in this top reference point. Let's highlight item. This is point and click plot. Now we have this curve. Let's save as is. Okay. And now let's go to plot our curve, force displacement curve, and go to combine displacement reaction force and add minus to reverse the curve and plot. Now we have this curve of force displacement of our compression test. Now let's plot. Let's animate our simulation and link to viewport. The first step of failure, and this step of is the failure, total failure of our cylinder of concrete. This is the first step of failure of our cylinder. As you can see here, we can this is the top or the maximum force can support by cylinder of concrete. And now we have the first step of failure of our cylinder. Until now, I hope you enjoy with this video. Don't forget to subscribe in my YouTube channel and like this video. See you in the next video.